Alright, let's do a quick, intense, complex bash tutorial, okay? So we have, let's assume that A, B, C are on the unit circle, yeah? Okay, so that A times A bar equals 1, and the same for B and C. And we got this expression for P, okay? And then our expression for E, so just assume this is part of the problem, okay? The expression for E is A plus C on 2, okay?
Oh,
The expression for D is B plus C on 2, okay? And the exercise is to show that PE is perpendicular. So P is the point P is represented by little p and little e is perpendicular to AD. Okay, does that make sense, Andy?
Yep.
Okay, so that's the exercise. I'll give you a bit of time, and then we'll spoil it in like a few minutes. Okay. Okay, so for people completely lost on what to do, let me give you the start, and then once you know what to do here, the rest should be routine algebra. Okay.
simple.
Okay, so to show things are perpendicular and complex bash, you basically show that one is a multiple of I of the other, because I multiplying by I rotates by 90 degrees. Okay, so you do D minus A, okay, over P minus E or E minus P, it doesn't really matter. Okay.
Wait, A minus D equals what?
Okay, and then if this ratio is a multiple of I, then it's imaginary, right? And the thing about imaginary numbers is when you conjugate it, they become negative. Yeah. So this is equal to its negative conjugate.
That's
Okay.
what I was thinking about when I said that.
Yeah.
I was not entirely wrong.
Okay, so
Oh,
from here, okay, if you know that how conjugation works, it distributes across everything, and then being on the unit circle makes it its inverse. You should be able to solve the rest of this problem routinely, okay? Even if you don't see any clever factorizations, if you just purely brute force it, there's not enough terms to stop you from getting there in a pretty reasonable time, okay? So I'll give you another chance to get there, okay? So I'll check up with you in a bit.
I don't know.
Alright, I hope that went well, but I'm gonna present Alex's solution to this, okay? One of our students. And so one of the key lessons here is it pays to simplify expressions before you go to battle, okay? So if you do P minus E, okay, and you just kind of left it as two fractions, you're gonna have a bit of a difficult time, okay? But if you get it all over the common denominator, say for example, so you got B minus A 3C plus B, and we can actually even ignore the 2 because it won't affect whether it's imaginary or not. But so 2B minus C. Okay, and then so to get the E there, you need to minus A plus C, B minus C, right? Okay. So when you do that, you get so these kind of terms are very nice to cancel. So you get 3bc plus b squared minus 3ac minus ab minus ab plus ac plus cb. Oh, oops, this is minus plus ac minus bc plus c squared and minus ab. There should be 4 terms. Okay.
What?
But,
You already did the
the what?
You already did the
I've already done the minus AB. Okay, yeah, so these are these 4 terms. I've already done the minus AB, so I've already got 4 terms here, yeah? Okay, and then so this is that, and then it simplifies a little bit. You get equals, so the 3bc becomes 2bc plus b squared, the minus 3ac becomes minus 2ac minus 2ab plus c squared on 2b, And then here it's where, like, if you're kind of savvy with complex bashing and you're kind of good with algebra, you see this, the top numerator can be factorized, okay? So it might not be that easy to see at first, but you'll kind of get the hang of it. So the key here is the b squared plus c squared and the 2bc becomes b plus c squared, and the minus 2a becomes this, and so you get a factor of b plus c outside of b plus c minus 2a over 2b minus c. Okay, and then so this is good actually, because b plus c on 2 is actually our d, right? And then so we also wanted to find out d minus a, or a minus d. So d minus a is b plus c on 2 minus a, which is b plus c minus 2a on 2. Okay, so you notice that's just exactly the same as that part. So then when you do p minus e, or was it e minus p? Yeah, p minus e over d minus a, yeah, that 2, well, we could ignore the 2 anyway, but the 2's actually cancel, and the b plus c minus 2a cancels, and you're just left with b plus c on b minus c. Okay, and you actually know that this is imaginary because these are the diagonals of a rhombus, but we could just check it anyway. So if you take the conjugate, you get b plus c bar bar on b minus c bar bar. Actually, maybe I can you can try and do this yourself, and then I'm gonna spoil it. Okay, so pause it and then I'll spoil it. Okay, I'm spoiling it. And if you take the conjugate, you get, so you times the top and bottom by bc, you get c plus b over c minus b, which is exactly the negative of the start, you know, the negative of b plus c, so it's imaginary. And that's a complex bash, okay? So if you know the points in terms of points on the unit circle and you want to show something's perpendicular, that's how you do it, okay?